Hello, everyone. My name is Angela Graves. I'm a Nursing Quality Management Coordinator in our Center for Professional Excellence and Inquiry. I was one of the sponsors along with Christine Taylor, our director. So we asked our SURF students to work on a project looking at lab errors. Lab errors are a very common problem, but they are multifaceted. They could be a result from a variety of different reasons. So it was really helpful to have the students take a look at all of that data and really drill down to some common trends. So we're excited to be able to use this data and furthering our work on looking at how we can improve this, how we can apply it to specific units. We do a process called a rapid process improvement, where we bring bedside nurses together along with other experts in the organization to look at a problem, look at the evidence, take data like this to really evaluate the best approach to solving that problem, and then work on implementing it in the organization. So excited to hear what Daniel and Jad have to present. Thank you.
Good morning, everyone. We're excited to share with you our results on lab errors, particularly reducing pre-analytical errors. Daniel Lee and I are the two class members staffed on this project. Before we begin, we want to, of course, thank our sponsor, Angela, and Dr. Christine Taylor, of course, and the SURF teaching team. So just a bit of background to put our need area in perspective, we look to a real-life scenario. Let us take an infant in the NICU that weighs less than 1 kilogram. This infant is in need of some surgical procedure, and so a TNS lab draw is ordered. Here, 2 ml of the 2.5 ml 30-day maximum has already been reached. If a lab error occurs, the sample is no longer viable and a redraw is required, forcing us to surpass the mandated maximum. This risks the safety of the neonates, inhibiting their growth, as well as disrupting hospital workflow. Hence, lab errors in neonates are extremely problematic if they occur often. Pbefore we begin, let's just put some sort of definitions to keep top of mind. So lab draw is just a blood draw. It's occurred by done by either a registered nurse or phlebotomist, either through the central line or a peripheral stick. A lab error is a failure in any of the identified process from ordering, drawing, and analyzing, displaying the results. And a pre-analytical error is an error that occurs during the collection of a lab specimen, such as a collection issue. In terms of our high-level project goal, we aim to develop and propose mitigations to reduce the number of lab errors at LPCH. We're going to do this by analyzing lab error data sets and highlighting interesting results, contextualizing the results, and finally developing and proposing mitigations. So we conducted multiple unit tours, and we observed the following RN lab flow process. The RN reviews the lab requests and gathers supplies. They then print labels and then log into a computer to scan a patient and label. The RN then conducts the blood draw and fixes labels on tubes and places them into a biohazard bag. The RN then relogs into a computer and clicks collect in Epic. They then transfer the bag to a pneumatic tube station where it will be sent to the lab for post-analytical processing. Before we discuss our findings, we thought it would be best to kind of contextualize our data set. So we used a iCare lab error data consisting of manually documented errors from March 2019 to March 2022. So we analyzed specifically data from 2021 to 2022. So important fields included patient information, error date and time, patient age and error, unit, collection issue type, and what happened. So just to clarify, so collection issue type showed the specific errors that occurred in the step flow diagram that we showed earlier, such as label issues, no collection info in Epic. What happened, the what happened form is a text entry form field which contains more background and contextual information on the particular error that was documented. With that, we move on to our data insights and mitigations.
Thanks, Jeff. As we said earlier, the data insights are off of the last 14 months from the beginning of 2021 until March of this year. So first, taking a look, we determined, taking a look at the data, we determined that the top 4 units that generate the most collection error types are in descending order: NICU, L&D, PICU, and CVICU, as highlighted in the red. These 4 units comprise of 70% of the total errors. Next, we looked at the most common error types. And so the most common error types are label issue, no collection information in Epic, quantity not sufficient for a type and screen, cord blood issue, and a TSN verification done at the same time in descending order. Don't worry about what these error types mean exactly, as we will cover some in later detail. But what's important to note is that these top 5 error types comprise of 75% of the total number of errors. And so breaking down the error types and zooming into the top 4 units that generate error types from PICU, NICU, L&D, and CVICU, we can see that if we target the top 4 units and the top 5 error type combinations, we can actually account for and mitigate a lot of errors. However, it's worth noting that there's still a substantial portion of errors highlighted in the blue for the top 5 error types that are generated still. And so our mitigation strategy that we recommend is 2 tiers, depending on the amount of resources that nurses can devote to this effort. The first tier is comprised of unit-specific mitigations, such as implementing placards at targeted units. And then the second tier of the mitigation strategy are hospital-wide mitigations, such as including announcements in a hospital newsletter. So coming back to this breakdown from previous, to determine which units, as well as which error types for which units to target, we use a threshold of 10 errors in the 14-month period, and identified those combinations here in the red. For these combinations, we dove deep into the iCare lab error data, specifically the free-form what happened field that Jab described previously, to uncover what the root causes are for the errors in the specific units, and appropriately design mitigations to target those root causes. And so for the sake of time, we analyzed the top 5 error types, but we will only cover the most common error type in the next slide. The most common error type is the label issue, which occurs during the following 2 steps: the print label step, or the affix labels to test tubes and place in biohazard bag step of the RN work process. So the root cause for this error type causes are that the label is cut off or overlapping, or that the label is not attached. And so the recommended mitigations are to clarify the label attachment process, and to implement a reminder to double check that labels are present and not cut off or overlapping, especially the barcodes. We recommend for this error type both tiers of mitigation strategy. The first tier being unit-specific, targeting NICU, L&D, PICU, and CVICU. The second tier targeting the entire hospital, since this error type is prevalent outside of the top 4 units. So here's an example of what a mitigation can look like. First, we have a catchy slogan provided by our kind sponsor, Angela, to check your test tubes before you pneumatic tube, meaning send off your test tube in the pneumatic tube system to the lab. On this example mitigation, we also have a reminder on what the root causes are, such as, or the mitigation is, such as to double check that the labels are present and not cut off or overlapping. And we also have an important statistic that kind of conveys how critical this error is, or how often it occurs. So 10 label issues occur on average every single month at LPCH. So this is an example mitigation, obviously not prescribed, but I thought pretty clever. So to summarize, we have the top 5 error types that we propose mitigations for. Combining all of that together, and just using the tier 1 unit specific approach, we address 47% of the errors. Using both tiers approach, unit specific as well as the hospital-wide approach, we address 75% of the total errors. So next steps, as Angela alluded to in the introduction, sponsors are going to present the findings to the RPI group. RPI group is going to align on error types and units to concentrate on, depending on the resources available. And they're going to generate mitigations and iterate upon those mitigations, including each unit's feedback. With that, we conclude. I guess we would like to acknowledge the following folks that played a big part in mentorship, insights, information, and everything, and are open for questions. No problem. Thank you for the opportunity.
I'll just make the comment that, we're all familiar with the challenges of doing new things in Epic. And so I love the fact that this very data-driven, analytics-based project can produce recommendations that are implementable in things that aren't going to be a challenge with Epic, either printing things out, better education, just targeting interventions that we can perform. That's it. Thanks for speaking.